that if you look at this, it's not this is not, because this is it's having this, and then this is just a straight chain, and then this is not. They're saying secondary, so because there is no hydrogen here, it shows that this is here on top here. So if you draw the structure formula, you see that this one is here, which shows that now this hydrocarbon, sorry, this carbon, it has this side and also has this carbon which is attached to the carbon atom with a functional group. So D becomes the most correct answer. Yes. So just guys, these are just my suggestions. There are so many ways how we can do so many questions we're gonna see, because we have different methods we use when you are doing these calculations. So let's see if we can what you wrote is what I'm going to write. So if it's a different method but you get the answer, then it's cool. Which one of the following is hydrolysis? Hydrolysis, people who watched my prediction, you saw. So this one is they're saying that which one of the following is hydrolysis. It means that which one of the following is hydrolysis reaction. So here you have this to form this. You have this to form this. This can't be hydrolysis because you are not adding water there. So you see this and this is the same reaction, but it's a reverse reaction. So this is not, this is hydration, and then this is obviously not, it's no, because we're not adding water there. So this one becomes the most correct answer. So yeah. Then we go to the next question, which is 1.4. They are saying that hydrochloric acid react with the excess. When you talk about excess, it means that it cannot be a limiting factor in that regard. So it means that just a moment. Just a moment, guys.
Recording in progress.
Right. Let's continue. Let's continue from where we stopped. I hope everyone is hearing me, né? Yeah, because it is just a live. Né? Yes. All right. If you don't hear me, okay. We go to the next question. What are they saying? Hello, everybody. Yeah. Go to the next question. What are they saying here? Zinc plus hydrochloric acid gives you zinc chloride plus hydrogen. Different conditions are shown in the diagram below. The mass of zinc is used is the same in both test tubes. Okay, meaning that the mass of zinc which is used is the same, but what is different? Remember, zinc is in excess, so it means that zinc cannot be a limiting reagent. But now what is happening here? If you look at here, is the same concentration. What is different here is the number, the volume. So what are they saying? Will the initial rate and the final volume of hydrogen produced in the test tube Y compared with that of X? So what will happen here? Initially, saying that how will the initial rate of reaction and the final volume, initial rate. So because it's initial rate, okay, produced in test tube Y, as compared to test tube X. So if you look at this, in test tube Y, what will happen here? initial rate of reaction in Y, and then initial volume of hydrogen in Y. So in here, we shall see that we're going to have more of Y, and then we're going to have initial rate of reaction in Y. So here is going to be this, and this is the most correct answer. So the answer becomes B. Then we go to the next question. We see that 1.5, the diagram below represent the mixture of nitrogen dioxide and nitrogen dioxide and dinitrogen tetraoxide. The nitrogen tetraoxide molecule at equilibrium in 1 decimeter cubed of container at T. All right. They're saying that the balanced equation for this reaction is this. Okay. What is here? We have 2 moles. Here we have 1 mole. Okay. None of the following is true for the equilibrium constant Kc for the reaction at Tc. So they are saying that Kc is 24. No, Kc is greater than 1. Kc is greater than 1. Yes, it could be. Is Kc greater than 1? Let's have to find out. We have to find out, because now Kc, remember Kc is equal to the product concentration to the exponent, maybe X in the product, okay, over reactant. So if you look at this is the product, but they say this is this. So how many are they? 1, 2, 3, 4, 5, 6. Just in case that this is 6. We don't have any unit here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If this is 12, and then this is 2 of them, so automatically this can't be 1. So Kc can't be greater than 1. Why? Because of this. So this is out. Kc is equal to 1. It can't be because they're not equal. Kc is greater than 0, yes, but is less than 1. I think that is the perfect answer for this, and then that becomes D, the most correct answer. Then we go to the next question. The next question, they are saying that all right, they are saying that next question, they are saying that the volume, okay, the reaction is at equilibrium in a closed container according to the following balanced equation. Copper is equal to copper 2. Copper oxide is equal to copper 2. Still is the same. It's copper. This is copper 2. This is copper 1. Gives you copper 1 plus oxygen. This is already as copper 1. This is already as copper 2. So if you don't know, sorry, but it's not for explanation everything. It's just to see which one is the most correct answer. Yes. The volume of container is now increased while the temperature remains constant. A new equilibrium is, okay, the volume is increased. So volume, how is the volume affect the Kc? Okay, we shall see. While the temperature remains the same. The moment temperature remains the same, means that Kc is always the same. But if you increase the volume, what does it mean? If you increase the volume, so here you have 4 units, 4 moles, while here you have 3 moles. So if you increase the volume, it's going to favor the reverse reaction. So let's go to the table and we see. Concentration of this decrease, no. Concentration of this one increases. So whenever there is remains the same, it is probably to be correct. But now the number of moles of this is gonna decrease. So we look at this. So now this one goes. So there is no any other option. So B becomes the most correct answer. So the concentration of oxygen remains the same. So 1.7 nitric acid and ethanoic acid, yes, what happens? Nitric acid and ethanoic acid, of the volume and concentration are compared, meaning that you have nitric acid, you have ethanoic acid, yes, so you compare the volume, they have equal volume, and the concentrations, these two are compared. Consider the following statement regarding to these regarding to this what solution. And what are they saying? That they have the same pH, they have different pH, they can't be with the same pH. Why? Because this is a weak acid, so it ionizes partially, while this is a strong acid, meaning that the pH of this is a little bit lower and this one is higher. Remember, when it's higher, it means that it's a weak acid. So now what happens? Both have the same electrical conductivity. No, amino acids, they have a strong electrical conductivity compared to others. So this is out. Both solutions require the same number of moles of potassium hydroxide for complementation. They're saying the same number of moles. They're not saying the same concentration, meaning that now the volume can be different. Let's see if both of them, they are monoprotic acids. Yes, if you look at nitric acid here, it has one hydrogen. And also if you look at this, it produces one hydrogen. So both of them are monoprotic acid. However much one is different. So therefore, it requires the same number of moles. I'm saying not concentration, meaning that the concentration might be different to reach neutralization. In other words, the volume used will be different, because if the volume is different and then the number of moles are the same, definitely the concentration will be different. So this and this, they become most correct answer. So do we have any option which has that? Yes. So C becomes the most correct answer. Yeah. We go to the next question, and then we see the apparatus in the diagram below is used for titration. Yeah, we use this to do the titration. But they are saying that hydrochloric acid and potassium hydroxide. Cool. In titration, the learner accidentally exceed the endpoint. Which one of the following will be true for titration mixture? If you are, both of them are strong acid and strong bases, so we expect the pH to be at least 7. But now the learner accidentally, remember you have hydrochloric acid, you are pouring it into you're not having the other way around. So it means that the pH is gonna be a little bit lower, or it's gonna be a little bit of acidic. So now the hydrogen ions will be greater than potassium hydroxyl ions, and the pH will be greater. Then now this one messes it up. And they're saying that hydrogen ions will be less, no, because we have more acid now. Then you're saying that then this one is also no. Then automatically this one becomes the most correct answer. But let's go through it. Hydrogen ions are greater than OH, yes, and the pH is less than. Is less than what? Is less than 0. Did I say that? This pH is greater than 7. No, man. No. It's this one. This means pH is supposed to be less than 7, meaning that 7, yeah. So this one becomes the most correct answer, not this one. Yeah. So the pH here, this one, hydrogen ion, will be greater than this, cool, and the pH is supposed to be less than 7, so that now it is acidic. This one makes it to be wrong, yeah. So the most correct answer there is A. Then we go to 1.9. 1.9, what are they saying here? The following hypothetical statement, standard reduction potentials relate to a galvanic cell. Okay, you have this, gives you this. You have this, gives you this. Okay, consider a statement in the galvanic cell. The EMF of the cell is equal to 20. Standard condition. If you have this minus this, then it gives you the volume, the voltage as that, or EMF. Okay, cool. Why is an anode? Why an anode? No. Why can't be an anode? Why? Because, and then X is oxidized. So if X is oxidized, let's see. Yes, X is gonna be oxidized. If this is oxidized, yes, this is cool. And don't forget, yes, so X is oxidized, then automatically Y is gonna be reduced. So it can't be the what? The anode. So the most correct answer is this and this. So you have to look at 1 and 3, where is C becomes the most correct answer. Then 10, they're saying that which one of the following have equation below will be the main reaction at anode during the electrolysis of concentrated. Now this word, that's why they even put it in capital letter. The moment they say concentrated copper chloride, yes, so it means that they are looking like molten copper chloride. It means that we're gonna have much more of, remember, we're gonna have much more of chloride, understand? And the anode is a positive in electrolytic cell, so the chloride will go to the positive charge. Therefore, chlorine is gonna be released there. So the most correct answer here is chlorine is gonna be released, so therefore D is gonna become the most correct answer. Then we go to the next question, that is now the section whereby just we have to talk about the naming, the nomenclature. Okay. Here, yes, let's go to the nomenclature and then we see how this one is going to be. Then here we are saying that A to H, below the table, 8 compounds. Okay, sharp. Let's say A is, okay, B, all right. Okay, let's go. Define the organic molecule. Basically, organic molecules are compounds with the one or more carbon atoms that are covalently linked to one another, or with another element. So basically, the organic molecule, organic compound, it must be basically carbon atoms. If it's more than one, it must be linked to one another. That's why we call them that carbon atom can have that ability of catenation, like joining one atom of carbon with another and then forms a long chain. It's one of the good properties of carbons, of carbon, yes. So basically that's an organic molecule. Write down the IUPAC name of compound E. So if you look at compound E, what are you going to say here? First, find out the longest chain, compound E. 1, 1, 2, 3, 4. No, 1, 2, 3, 4. Because here I have the double bond. But when I was going through this structure, as you see it there, something was not right. I don't know whether they did it on purpose, but it can't be, because this is a mistake. I don't know how it did happen. Maybe through printing, this molecule does not exist. See this? It's supposed to have 3. But they didn't put a 3 there. I don't know how they will mark it, but it had to be with a 3 so that it is a methyl. Yes, but let's just assume that we put a 3 there so that we have a correct naming as a methyl. Right. So it's gonna be 1, 2, 3, 4. So it's gonna be bute. Bute. It's gonna be bute. But because it's a double bond, so it's gonna be bute. So it's 1 is on carbon atom number 1. Bute 1. You see, it's on carbon atom number 1. So it's gonna be bute 1 in. Bute 1 in. Now I have this side group and I have this side group. So you have the first side group is on carbon atom number 2. So it's gonna be 2, comma. The second side group is 1, 2, 3, 3. Then dash di. What is it? These are methyls. Dimethyl butene 1 in. 2, 3 dimethyl butene 1 in. So basically, how many marks are there? They'll give you a mark there, and they'll also give you a mark there. At least you get those 2 marks. Yes. Then we go to the next question, which is what is H? Hypack name of H. What is H? H is here. This is a carboxylic acid. It is a carboxylic acid. So, this no, they are not looking for this. They're looking for H. So this is a ketone. So 1, 2, 3, 4. So it's gonna be butane. Remember, I told you that when it's not alkyl, if it's not alkene. So here you have to write up to there. Butane. This is a ketone which ends with on. So it's gonna be butane 1, 2, 2 on. So butane 2 on. So basically that is it. So that you get 2 marks for the chain and then the position there. Then we go to write down the structure formula of compound B. When they say the structure formula of compound B, let me just clear it up so that we see exactly what are they saying. The structure formula of compound B. What is compound B? Okay, it's here. What is it? It looks to be an ester. So it's gonna be CH3. You put hydrogens. The hydrogens are supposed to be there. Might not put them here. And then this one, because there's no shortage of hydrogen here, so automatically this becomes a chain. CH, that's 1. CH, that's 2. CH, that's 3. Now I put C. 1, 2, 3. O there, and then O, and then hydrogen. So you put the hydrogens. No man. Yes, you put the hydrogens. Yeah, it doesn't end with it's an ester. So it's C. You put the hydrogens completely. Yeah, so that's what the structure formula, but they are talking about in here for compound B. Then we go to structure formula for compound C. Now it is compound C. So here they want the structure formula for compound C. Okay, let's write it. Xn. Xn is 1, 2, 3, 4, 5, 6. It's Xn. Difluoro is 3, 3. 3, 3 difluoro. Let me just count from here. 1, 1, 2, 3. So I have a fluoride here and I have a fluoride here. Okay. And then you have 4 methyl, meaning that if I come from this 1, 2, 3, 4, so I have a methyl here. Is it methyl? It's ethyl. So I put hydrogens. So you're supposed to have now the hydrogens. You fill it with the hydrogens. So that's the structure which you're supposed to draw when it came to that. Then I don't understand what you are saying. Aneliswa. Don't understand. But I think we are getting there. Hope you are hearing me properly. Yes. If you're not hearing me properly, let me know in the comment section. Yeah. All right. Let's go to the next question, and then we see how did we perform this paper. Hey, you guys, I salute you. At this time, you are awake. Okay. All right. Let's go to question 2 point. Yes, H, we are done with it. Write down the structure formula of B. Did I write? Yes, I'm done with this. Done with this, I'm done with that. The general formula of homologous series to which compound E belong. Where is compound E? Compound E is an alkene. Remember when I was reminding you how to write this? I said that alkene is CH2N. We don't add anything because alkane we add 2 and alkyne we subtract 2. Yes. Structure formula for functional group of F. So we go to functional group of F. F, it is a keton. Therefore, here you just come and write the structure formula of so that's basically what you're supposed to write like that. However, sometimes some people they put a bracket like that, so it's the same thing. It's cool. Yes. And then sometimes people add alkyl group that side and alkyl group that side. Still, it's cool. You'll get a mark in that regard. So in that case, the structure formula, we say that it looks like that. Whatever you write it is cool. Then IPAC name of alcohol needed to produce compound B. Where is compound B? Compound B is, we say that compound B is an ester. Since compound B is an ester, let's see which alcohol is used to do what? To remove or to form this ester. Remember I told you guys that the alcohol comes from the carbon atom without a double without the hydrogen. No, that's the carboxylic acid. So you see this carbon atom, then it means that this part came from the carboxylic acid because this carbon atom didn't have a hydrogen. And then this is where the alcohol is coming from. Since it's one carbon atom, therefore it's going to be CH3 or H. Did I say structure formula? If they say the structure formula, IPAC name of alcohol, they just want the IPAC name. Therefore, if the IPAC name, then I'm just gonna say methanol. That's it. Because methanol doesn't have the name, the position, because it's just one carbon atom, and ethane doesn't have the position because it's two carbon atoms. Yes. They are saying that write down letters of the compound that is functional isomer of compound G. Functional isomer of compound G. So now we go back to compound G. G is the carboxylic acid. They are saying functional isomer. If it comes to functional isomer, then it means that they want an ester. So you have to look for the what? For the ester. But it must have the same number of carbon atoms. So the only ester we have here is this. But we have to find out if they have the same number. 1, 2 times 3. Meaning that 1, 4, yes, 5, 6. So we come here and we count 1, 2, 3, 4, 5, 6. So automatically B and G are functional isomer. What did they say? So the answer here becomes B because they are looking for the functional isomer of G. A chain isomer for each other. Chain isomer. Let me check here. Functional isomer of G. Functional isomer of G. Yes. Okay. We got it. Then they're saying that chain isomer of each other. Chain isomer. Chain isomer. Okay. This is a carboxylic acid. Do you have any other carboxylic acid? This is another carboxylic acid, but this is heptanoic acid. This is hexanoic acid, so it can't work. This one is a carboxylic acid. Let's look. 1, 2, 3, 4, 5, 6. So it has 6 carbons. And even hexanoic acid is also having 6 carbons. Yeah, so definitely D and G. D and G. So D and G, they are chain isomer. Remember that it's supposed to be the same functional group. It's just the different arrangement of atoms on the parent chain. It's the one which changes, so that now, yeah. So we go to the next one, the next question, and then we see. So you have got it. You have got that one. You have got that one. Oh, you finished question 2. Okay, let's go to question 3, and then we find out how did you perform this question 2. They're saying the relationship between the boiling point and the molecular mass of aldehydes, carboxylic acid, aldehydes, carboxylic acids, and primary alcohol is investigated. Okay, the curve PQ, PR, and S are obtained. All compounds used a straight chain. This is a key point, a straight chain. So it means that you won't be disturbed. Define boiling point. This one you know. Temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. And then, yes. So definition you know. In most cases, I don't talk about them. Yes. 3.2, because it doesn't change. Write down the conclusion that could be. Okay, could be made for P. So where is P? Without even looking at what is P, but you see that it increases. The boiling point increases as this is increasing. We always start with the y-axis, because the y-axis depends on x-axis. You can't say that the mass increases as boiling point increases. No, it's the boiling point increases as the mass increases. Yes, why? Because the mass caused the boiling point to increase. If you have reversed, maybe they could give you a tick, but that's the most correct answer. Then they're saying that explain the answer and the structure. Okay. In this case, because it is the same molecule, because the same molecule, it means that you will have the same type of intermolecular forces of attraction. But as the mass increase, the London forces increase. So it means that as the mass increase, the London forces for this compound P increase, and then this will require more heat to break these bonds so that it can boil. You understand? So that's how we're supposed to explain, talking about London forces increasing the boiling point because of the high amount of energy which will be required to break those bonds. Then you get it. Yes. Then they're saying that curve R represents alcohol. Curve R, where is curve R? Represents the alcohol. Okay, if this is alcohol, then automatically this is carboxylic acid, and then this is aldehyde. Yes. So if this is alcohol, then this is carboxylic acid. So why am I saying that? I'm just saying because they have said R is alcohol. And then if you look at the intermolecular forces of attraction here on S, on this one has dipole forces and London forces. This one has hydrogen bonds and the London force. This one has London, hydrogen, and then dipole. You see, it means that this will require more heat to be broken down. Therefore, its boiling point is a little bit higher compared to alcohol, and then this one, hydrogen bonds is stronger than dipole. Therefore, the boiling point is higher than that of. Okay, let's go to the question and then we see. Which homologous series is represented by S? So we have said it. So it is an aldehyde. And they are saying that explain your answer. So I've tried to explain that it has London force, and London force and dipole forces which are weaker than the hydrogen bond, yes, which are, and London force which are found in alcohol. Therefore, alcohol will require more heat to break its bond so that it can boil. Hence, its boiling point is higher than that of the aldehyde. So basically, that's what you're supposed to explain. My words could be that too much. Maybe you explained in a different version. Yeah, still it's not a big deal. As long as you have talked about the things which they want you to talk about. Then we go to the next question, which is saying that molecular mass of compound with a boiling point 97. Okay, R is right, graph R, write down the molecular mass. Okay, we have to go back and we'll find out where it's 97. They say 97. Yeah, unfortunately, boiling point 97. The graph can't show nice of R, the boiling point around 97. So if you look at 97, just check here on this paper if I can find 97 is around here. So I have to draw a line touching down. Yes, and basically if you check here, it's gonna be was 50, 70, then automatically it's 60. But if you calculate the boxes, the small boxes, you'll find out that it is 60. So the answer here will become 60 because that's the molecular mass. So the molecular mass is going to be 60. So the IPAC name of compound is, this is 2 marks. 2 marks there. Where do I get those 2 marks from? So basically here, you need to find out which alcohol has 60. That's all. Yes, which alcohol has a 60. So it's easy to calculate. How do you calculate? You can use the formula of CnH2n, yes, plus 1. Yes, plus 1. So basically that's the formula you're supposed to use, and then you're able to find, if you substitute, you'll find out that it is CH3, CH2, CH2, OH. Why this? Because why not branched? Why not secondary alcohol? Yes, because it could be here, because here at the beginning they said these are straight chain molecules, so that makes it to be not that way, not to talk about the branched or yes. So they're saying that, so the answer in this case is supposed to be, they say IPAC name, so it's gonna be 1, 2, 3. So it's gonna be propanol. That's what they want. Propanol. Yes. Maybe they will give a mark for that, and also they give a mark for the main chain. So guys, that's how you're supposed to answer that question. Okay, let's go to the next question. Someone is telling me that, yeah, just go check 1.9. Okay, I'll check. I'll check an NC. Yeah, I'll check an NC. But let's go to the next question. What are they saying? They are saying that, oh, I'm skipping. Okay, I'm skipping a question. 3.6, they're saying two compounds A and B used in this investigation have a molecular mass of this, okay, and it has a boiling point of this. A and B have the same molecular mass, né? Good. And it has a boiling point of this. Okay, B boiling point is this. All right, explain the difference in the boiling point by referring to the structure of. Yeah, definitely, if the two compounds A and B are used to investigate, okay, in this investigation, have the same molecular mass. The moment they have the same molecular mass, so what is going to make them to be different in terms of the boiling point and melting point is going to be whether it's a straight chain or it's a branched chain. So in this case, it's gonna be A is gonna be, okay, sharp, and then this shows. So it means that the one which has the highest boiling point is going to be a straight chain, and then one which has the lower boiling point is going to be a branched chain. So how do you explain this? So B has a higher boiling point, so B is going to be straight chain, while A is going to be branched chain. Why? Because when it is straight chain, it has a large surface. It has a large surface or a large size, and then this creates a large polarity. And then once there is high polarity, you require more heat to break these bonds. While B, while A, yes, which is a branched, will have a small surface, therefore it is compact. The polarity is going to be small, or it's going to be lower, and then it will require less heat to break these bonds, hence slow boiling point. So when you're explaining this, you're supposed to explain using the size and how this side accommodate the bonds, the polarity, yes, and then how much heat do you need to break these bonds compared to the other one, and then you are able to get those 3 marks. Yes. Then we go to question 4. Question 4. Question 4. What is happening in question 4? All right. Let's look at question 4. Let me just give you 1 minute. Just 1 minute. Back, just wanted to take some water, because yeah, when you talk too much, yeah, they happen. All right, let's continue to the next question, and then we see. Okay, they're saying that cracking. When you talk about cracking, you are breaking molecule. The definition is there. Define cracking. Cracking means breaking down large molecules into smaller useful molecules. They want the word useful. Large molecules into smaller useful molecules. Yeah. The smaller useful molecules can be, yes, used in different activities. Okay, write down the value of X, Y, and Z. Now this you have to balance the equation. So that's it. 3 marks. So it means that you need to know what is X, you know what is Y, and you know what is Z. Okay, let's start with X. Let's start and we see carbon, 6 carbon. 6 carbon. 6 carbon akarane. So, this is 16. So it's 6 plus 6. See, 6 is equal to 6 plus 6. So that's 12. What is short here is equal to 4. Is it? Is it what is short there? Is it 6 plus 6? Yeah. So what is short there is equal to what? Is equal to what? Is equal to 4. So automatically, then it means that okay, and then Z Y. Is Y? Yes, Y, and then X. Okay, sharp. Now you have X. This is 16. Eh? This plus this is 12. So the balance here is gonna be what? It's gonna be 4. So okay, we put the 4 there. But don't forget that this is 2. So automatically, then it means that Y is supposed to be 2. You see? Yeah, if Y is 2, then automatically carbon atoms are balanced. Why are they balanced? Because 2 times 2 makes them 4, plus this makes them 10, plus this makes them 12. So it means that Y is equal to 2. Y is that. Then now, if I have hydrogen here, hydrogen. Okay, now let's go to X. X here, X hydrogen is 34. Ne? And then you can divide, you get the answer, but hydrogen is equal to 34. So how do I get this and this? First of all, this, how many carbon atoms makes it to be an alkane? That's the first option you can go with. Yes, if is C6 CnH2n plus 2. Ne? Yes. So so if this is 6, what is X? So it's gonna be times 2, which is 12, plus 2, which is 14. So it means that X is gonna be 14. You have different ways how you can find it out, because what they want here, they want to say this is 14. That's it. And then now, yes, so Z is gonna be what? Z, now I have this carbon atom. There are 2. So if there are 2 here, then definitely is gonna give you H. Oh, this is times 2. So it's so it's gonna be 1, 3. which makes it to be CH3, CH3. You see? Yes. To make it to be 6, in the other words. So it means that Z is equal to 3. So that's how you're supposed to say. We say that X is equal to, what did I say here? X is equal to 14. Z is equal to 3, and Y is equal to 2. I was putting this in a different angle. Yes, X is equal to 14, Y is equal to 2, and then Z is equal to 3. Then they are saying that X is equal to 12. No, X is not equal to 12. Someone said, don't talk about that. All right. Okay, let's continue, guys. All right. Saying that this undergoes complete combustion. Guys, whenever they ask you about combustion, it's a simple thing. Why is it a simple thing? Is you're supposed to do the same thing. See, you produce carbon dioxide plus water as a product. But now they're saying that this compound CH14, yes, CH14. Even here is showing here CH14. So automatically this is 14. You see, it can't be X12. You see, yeah. Anyway, you can also use that technique just to identify it. CH, okay, CH14, C6H14 plus oxygen, then the reaction. So here you have to balance the equation. I try to balance. You know, this is it first introduced 2. After that, had to increase because oxygen was not balancing. I had to introduce a half, but we don't teach halves here. So this is 2, and then this was 19. Oxygen was 19, and then carbon dioxide is 12, and then oxygen, water is 14. So basically, after balancing, that's what I found out. That C6H14, then this one was 2, and then plus oxygen, which is 19, gives you 12 carbon dioxide plus 14 water here. Yes. So if you check and you find out that this is a gas, and then this is a liquid, you find out that it is balanced. Yes. So this is what they wanted you to write. If it's, yes. Then we go to the next question. Let's go to the next question. Consider the reaction 1 and 3. Consider the reaction 1 and 3. Ish. No. Kids, I hope you guys pass. Yes. Consider reaction 1 and 3. 1 to 3. 1 to 3. We call this reaction synthesis, manufacturing. A and B represents organic compounds that are positional isomers, meaning that is the same molecular, same structure, just the position of the substrate is different. In other words, one is a major product and one is a minor product. That is what is behind this. Remember, when you're doing this, we produce major products and minor products. Okay, let's go to the question and then we find out. Define position isomer structure molecules, the same molecular formula, but different position of the substituents or functional group. Yes. All right. The type of reaction represented by 1. Now, let me see. You have this is an alkene. It has a double bond. Know why? Because here there is not 2 and here there is not 2. Meaning that there is a double bond in there. It's a condensed structure formula. Ne? Yes, so it's a double bond. So it's an alkene. Alkene. You understand? Then you added this. So now there is something which you need to do. No. 1, 2, 3, 4, 5. Ne? So 1, 2, 3, 4, 5. Whereby you have this, a double bond there. You have a double bond there. So it looks like that. There's something which I want to show you. Yeah, the double bond is 1. The bond is there. And the other side plus hydrochloric acid, you produce A and B. So the first compound, what's going to happen? The first compound, then let me show you another compound. The first compound, this is going to break. Hydrogen is going to come here and the chloride is going to come there. The second compound, chloride is going to come there and then hydrogen is going to come here. And this one is the major product. This is a minor product. But now, look, if you look at this and this, it's the same molecule. But now, remember now this one is gone already because after it has broken. This and this is the same thing. But what happens here is these are just positional isomers. The position of this has changed. This is on carbon atom number 2 while it is on carbon atom number 3. Yeah. That's why they said this. And then they say that they used A. Now, among those two, which one is A? Okay, we're going to know A by this. See? You see that now this OH is on carbon atom number 2. So it means that in this case, they used the one which is on carbon atom number 2. They use the minor one. Understand? Yes. Okay. Now, they are saying that write down the reaction that takes place by 1. There is 1. Because this, I'm adding this. So it's going to be hydrohalogenation. Would be additional reaction or hydrohalogenation. Both answers could be correct because they are not specific. Structure formula of compound B. We talk about structure formula of compound B. You see now, they are talking about the major one, major product. You see, this is what you're supposed to write. But don't forget to put hydrogens. See, yes, that's what you're supposed to write in that case. So automatically, this is the hydrogen and then this is hydrogen. The hydrogens must be there. These bonds, they don't hang outside just like that. So there you get the answer. Let me see, someone is saying okay. All right. Let's go to the next question. And then saying that yeah, so we are done with this, and then we go to this one. Go to this one. saying that write the structure formula of compound B. Okay, we are done with that. Formula of X. Now where is X? X, now remember I have this which I added on A. So now this is hydrolysis. I don't know why they brought it back, because they brought it already before. There is a question I saw where they are asking about hydrolysis. So automatically this plus this, it gives you that. So it means that this was this one is going to be removed from this, so that yes. So the structure formula, they're saying that the structure formula of compound, oh, what did I say, is going to be hydrochloric acid. Why? Because the hydrochloric acid was replaced by water. Actually, the chloride is one which is replaced by water, but don't forget that water comes with another hydrogen. Therefore, X becomes HCl. Yeah, it can be hydrochloric acid or hydrogen chloride, but since it's in aqueous, then definitely it is hydrochloric acid, and they want the formula. Then they're asking you inorganic reagent in a reaction 3. You are removing the water to alkene again. Definitely this is going to be what? It's going to be dehydration. So it's going to be sulfuric acid, conc, sulfuric acid. Don't forget that when you're forming that, you require some heat, but they are not asking you, they are saying inorganic reagent. So in this case, sulfuric acid would be the best answer. However, if you wrote concentrated phosphoric acid, is also correct. Maybe the books, they are not talking about it, but it could be there in the what? In the memorandum. Yes, so concentrated phosphoric acid is also allowed in that regard. Then we go to the next question. Beside heat, write down the reaction condition needed for this conversion. Beside heat. Yeah. Compound A. Let's go back to compound A. Compound A, all right, we saw it. Compound A can be converted directly to compound E. Okay, yes, from here to here. From here, from hydrogen halide, this one, to direct to alkene. So what do you need there? In that case, the first thing you need to know that no water is needed. Eh? Yes, that's the first thing. Then number 2, strong base. You use a strong base. Strong base. In this case, maybe you said strong base, potassium hydroxide, or you can say sodium hydroxide. Still, when you say that, still you give you a mark. Write down to, as I told you, that this is just there are so many answers. I may not finish everything, and the way how you do the calculation, as we shall see, may not be the same as long as you get the correct answer. Now, write down the term, 2 terms that describes the type of reaction. So the type of reaction, remember you are from hydrogen halide, halogen from this, the haloalkane. You are from the haloalkane, then you are going to an alkene with a double bond. So it means that first of all, I'm removing this and this. So I can say elimination. Yes, so you saying elimination. Let me see, what did they say here? Oh, they said
Recording in
okay,
progress.
I'm back just that you Yeah, we are in Mzanzi. Yes, Electric had gone. They're saying that someone is asking me, is concentrated or, yeah, when you say concentrated, when you say dilute, then definitely there is water there. So it's better to say concentrated. All right, let's continue to the next question. Let's go into the next question. But we will mark the strong base. Concentrated strong base is fine, but we want that strong base. The base must be strong and no water, because we said no water. Definitely it can't be dilute. Okay, we go to the next. This question is finished. All right, let's go to the next question. All right, they say, here we are saying that, all right, here we are saying that the reaction below, the reaction between excess, guys, the word excess is very, very paramount here. You have to take note of that. Hydrochloric acid and the sodium thiosulfate is used to investigate the factor that, all right, it's disturbing now. All right, they're saying that the time taken, all right, the time taken, all right, okay, let me come back. Of the reactant with the time. So when you say the word rate, then automatically you have mentioned the word time. So change in the concentration of product over time. Understand? Yes. Or could be volume, it could be mass, it could be as long as what you say there is related to time. Write down the independent variable. Here, independent variable, basically we look at what is changing in this experiment. And then based on what I see here, they say that the volume of sodium thiosulfate is changing 50, 40, 30. And also the concentration is changing. Definitely, even this one is changing. So concentration will determine the rate or the time, how much time is being produced. So this, yes, could be the first, or you can say volume, even volume here. Why? Because basically when you find the number of moles, definitely it's going to relate it to the concentration. This is changing, we control this, we also control this, and then we keep on changing this to see what is happening here. So probably the people who wrote volume will get a mark, and the people who wrote concentration might get a mark in there. So calculate the value of P, is 3 marks. So what does it mean? It means that it is something which is small, and then you can get the marks in there. So what are you going to do when you reach to this? So let's try and find out. This is some of questions which are not general questions. They're just, you have to think. All right, here we know the volume which we started with without any addition, and the concentration. So it means that we can find the number of moles which is in run number 1. For example, you will say that number of moles is equal to concentration times volume. So in this case, we're going to say that number of moles is equal to concentration, which is 0.13 times volume, which is in this case it is 50. But don't forget that this is not decimeter cubed, so I have to go convert it into decimeter cubed, and then I divide it by 1,000, and then when you divide it on your calculator, it is mostly likely to give you 0.065. You have to calculate Did I say 0.065? So you have to calculate and then find out the actual answer. Maybe when I was doing it, did not do the perfect calculation. Yes, but that's how you're supposed to do it. But now, since now I know this, I can go to this. Yes, you understand? I can go to this, or I can use what I've got here and then I compare it with what is here. I can use number 2 to prove that my method is correct, but because we have 3 marks, so we have to rush to the answer. So in this case, we're gonna say that the number of moles here, let's look at the number of moles here. The number of moles here is gonna be equal to, yes, this 0.0065, yes, times the volume, which is 30. So I'm comparing this with this, yeah, but divide by, in this case, this is 30, but the total volume is 30 plus 20. So the number of moles are in this of sodium thiosulfate are in the 30, but the total volume is what? Is 20. So sorry, no, it's not 20, it's 20 plus 30, which makes it to be 50. So the number of moles in this case will be, when you calculate, you will calculate and then you find out the perfect answer, and then 0.0039. So now these are the number of moles. These are the number of moles which we find here. You understand? So we can use this and then we find the concentration. So therefore the concentration is going to be equal to, in this case, we supposed to, now we have the number of moles divided by the volume. So the concentration is going to be equal to 0.0039, because these are the number of moles divided by the total volume, which is 50. But now 50, because I'm looking for concentration, this is 50 cubic centimeters, so I have to convert it into decimeter cubed, and then once you get here, it will be approximately 0.7, or maybe let's take decimal places of 3, 0.078 molar. So this will be this. And then this also shows you that if you had got a bigger answer here from this, then your answer is what? Is wrong. So that's why this answer is supposed to be in that direction. So that's how you're supposed to calculate. If you have another method you can use, because this is just to find out what exactly they use, there's no general formula for this. Yes, so it's still good. Once you get the correct answer, still they'll give you your marks. So we're done with that. Then let's go to question 5.4. They're saying that when 0.2 grams of sulfur has formed in a run 1, yes, 0.2 grams of sulfur has formed in a run 1, the cross becomes invisible, meaning that that's the end point. Yes, calculate the average rate rate with respect to sodium thiosulfate. So what am I going to look at here? Remember that rate, let me clean up here. Remember that rate of reaction is equal to change, because they said here in terms of this grams per second. So it means a change in mass over change in time. Let me check and see if there is someone talking to me. Acid and bases, show me who is the boss. Okay, sorry. Okay. All right, let's continue, and then we go to the next question. Then here, calculate the average reaction rate with respect to sodium thiosulfate. So now we have seen that we know this. We rate is equal to mass, change in mass over change in time. But now we know the time here, which is 20.4. So, but we don't know the mass. So it means that we're supposed to look for the mass. So how are we going to find the mass? Remember that we can find the number of the mass. Remember, mass is number of moles is equal to mass over molar mass. But how are you going to find the mass? Because we don't have the mass, have any mass. Still, we can use number of moles is equal to concentration times volume. At least we have this. We have the concentration, we have the volume. So number of moles is equal to 0.13. We know it here. 0.13 is there. And then times the volume. The volume, do you know the volume? Do you know the volume? Yes, we know the volume as 50. So we know volume as 50, but it's supposed to be molar volume. So I divide it by Alright, yeah, this is just internet which is disturbing. Alright, we're saying that number of moles here, now we know the mass, we know the number of moles. So now number of moles in this case is going to be 0.0065 is equal to the mass which we don't know, over the molar mass. In this case, you have to look at the molar mass. With the molar mass, molar mass of sodium thiosulfate. So automatically, sodium thiosulfate, which this is 23 plus 32 times 2 plus 16. Let's check on the periodic table because I'm getting it from the head. Plus times 3. Yes. So when you add, and then you have to add, and then it means that it's this times this. So the number of mole mass is going to be equal to, when you multiply this, the whole thing, this with this, you understand? The mass is going to be 1.027 grams. Understand? Yes. So now it means that that is the mass which we started with. So it means that why? Because guys, don't forget that this hydrochloric acid was in excess. So it is zinc which is going to act as a limiting reagent. Therefore, all of it was used up. When you're subtracting, it's supposed to be subtract. Remember, it's final and the minus initial. So all of it was used up. You understand? Yes. And even when you check here, here with the sulfur, you find out that it is the same thing. All right. So now we say that now rate is going to be equal to 1.027 minus 0, and then divided by 20.4. Is it 20.4? Let me check and confirm. Yes, 20.4 minus 0. So rate of reaction, in this case, rate of reaction is going to be giving me, did I say rate? Yeah, in terms of grams. Yes, it's going to be 0.03 grams per second. Yes, then that makes our answer to be that. Then we go to the next question. Go to the next question and then find out. When we go to the next question, we will find out that, okay, next question is they're saying that another investigation, yes, another investigation is performed at a different temperature. Sketch the Maxwell distribution curve for reaction at 20 degrees C. 20 degrees C, when you look at it here, 20 degrees C, where is it? 20 degrees C. Okay, it means that here, 20 degrees C. Okay, yeah. So it means that the 20 degrees C, and then label it on the same axis, then it will be obtained at 35 degrees C. So in this case, you are increasing the kinetic energy. So whenever you talk about Maxwell distribution curve, so automatically it means that you show us which one is going to have enough kinetic energy. So particles, number of particles. So if this is the first, and then that is the number of particles with enough sufficient energy, when you increase the temperature, yes, it's gonna flatten and increase the number of particles. It's gonna flatten and then it increases the number of particles. Yes, so you see that the number of particles, yeah, like that. So all this now, which are added more, yes, it means that now more particles will have. Then you tell us this number of particles, and then you put a caption so that maybe we give you a mark here, we give you a mark here, and then these labels of the axis. Then they are saying that explain the effect of temperature on the reaction rate in terms of collision theory. Increase in temperature increases the number of particles with sufficient energy. So it means that you will have more perfect collision per unit time, resulting in increase in the rate of reaction. So basically, when you increase the temperature, you're increasing the kinetic energy of the system, and then this will lead to more effective collision, and then per unit time, and then this increase the rate of reaction. So basically, that's what you're supposed to talk about or to link. Let's go to chemical equilibrium. I think chemical equilibrium was very simple and easy to interpret. And those people who watched my prediction, I think I gave you a question which is almost the same like this, exactly. If it does not, okay, let's look at it. Consider the hypothetical reaction of, this is the volume. It's very important. Close the system container, okay, sharp. And they're saying the graph below shows the change in the amount of reactant and product over time. Okay, cool. Then they're saying that write down the meaning of reversible reaction. What does it mean? Reversible reaction. It means reactants can be converted to product, and product can be converted to reactants. That's when the reactants and products can be converted here. Yes. So state reactions principle. This one is also. Some people, they just talk. They are words. There are some things we are looking at when you are answering these definitions. They don't change. It remains the same. A principle remains a principle. But here you have to talk about the equilibrium, and then to have to talk about the stress which has been introduced. Then you have to talk about how is the system going to uh, counteract this stress, and then how is the equilibrium going to shift. So basically, as it shifts, it tries to remove the problem or the stress you have introduced. But some people, they just leave some points, and then this is a principle whereby you get it or you lose it. It is all or nothing law. Either get all the marks, the 2 marks, or you lose everything if you skip out something. Okay, a change with the change was made at equilibrium at this point, this seconds. Okay, write down the change that was made at this point. So if you look at it, this is the product, and then they added a product. See, so there is addition of product or addition of A. Then they're saying that and then the moment you added, then it reversed. You see that now it became a reactant. You see, yes. Okay, they're saying that the Chinese principle explain how the system react to this change. Use this principle how the system react to when more product, when the product was added. Yes. So what is the stress? So it means that the system had to shift so that to reduce the amount of product you have added. So therefore, it will favor the reverse reaction so that the amount of product which has been added can be decreased. So you talk about the stress. How is the system going to change based on the stress or based on the what you have added in there? So basically, that's why it's 2 marks. Calculate the equilibrium constant at okay. Equilibrium constant. Okay. Now you need to what 120. Yes. Okay. They are looking at 120 after it has reversed. Okay. Let's look at what you talk about here. You can use a different method or you can use rice method. Because it's 4 marks, it means that it doesn't have that much details. You're supposed to do rice. And then this is elements, so you have A, you have B, and then you have AB. Something is very important here. Look, guys, here the reaction reversed. This was the reactant, but here is the product. See, so this is the product now. And then the one which was, you see that this was a product, now it became a reactant. So A and B, they are reactants. Yes, that's why I put them on this side. So mole ratio, based on the mole ratio, this is 2, and then these are 1 1. So meaning that you have 2 here, have 1 1. Initial concentration you just get from the graph. Here it is 2. Is it 2? Yes, it is 2. A B is 2, ne? B is, check, it's B is 2. So I come here, I put 2 on B. They say that no. Look, this is the initial what you started with. So what you started with here, B here, initial I started from here, so it's 4, and then A started from 10, and then AB started from AB started from 10. AB, ne? B started from 6. You see? Yeah. So it means that A started from 10, and then B started from 4, and then AB started from 6. You see? A started from here, which is 10. AB started from 6, and then B started from here. All of them, they started from here, started from 4. Now, since I know what I started with, now what is at equilibrium? Okay, now AB, it is 10. AB, it is 10. That's what is at equilibrium. And then B is 2, and also A is 8. So B is 2, and then this one is 8. Now to get the change, what happened at equilibrium? Yes, this is what they used. So now I need to know what is remaining at. Yes, so now this minus this, I'm gonna get 2. This minus this, I'm gonna get 2. And this minus this, I'm gonna get 4. Actually, it shows us check. It's 2, 1, 1. Now, how much volume did they use? How much volume did they use? They used 4 decimeter cubed. Therefore, I'm gonna say 2 divided by 4, which gives me 0.5. 2 divided by 4 gives me 0.5. 4 divided by 4 gives me 0, which gives me 1. Yes. Now I say Kc is equal to the concentration of AB, because it is the product over, but how many moles? There are 2, squared over the concentration of A and the concentration of B. Yes, but Kc is equal to A is 1. See, the concentration is 1 squared divided by A, which is 0.5, and then times B, which is 0.5, which gives me Kc to be 4. So basically, that's what you were supposed to do when it came to that. Okay. Then we go to the next question. The next question, what are they saying? Next question. All right. Then they're saying that, so we are done with that. They're saying that calculate, okay, at 130 the temperature of the system decreased. 130, let's go check. 130, okay, temperature decreased. When it decreased, what happened? The reaction increased. So it means that this reaction is exothermic. Yes, it's exothermic. So let's look at it and we see. The temperature decreased, which means that the reaction is exothermic. Okay, they're saying that write down the potential diagram for this reaction. So automatically, if it's exothermic, then the potential diagram talk about exothermic. So the energy is lost. Yes, whereby here is gonna be AB, and then here just progress, reaction progress, and then here is the potential energy. Then it's gonna be A plus B, and then this is gonna be activation energy, and then this is gonna be change, enthalpy change, and then this is gonna be activation energy. So basically the graph is gonna be like that, but it wants to show that it is an exothermic reaction. We go to the next question. What are they saying? Initial yes, okay. Will the equilibrium constant Kc at 100 be greater than, less than, or equal to at this? Explain your answer. Definitely is going to be greater than. Why? Because this reaction is exothermic. It is going to be favored by decrease in temperature, and then more products are going to be formed, and then once more products are formed, the Kc value is going to increase. Don't forget that Kc value can only be increased by temperature. All right. Then we go to the next question, which is question. The initial reaction takes place in the presence of a catalyst. At this, describe how the change will be observed on the graph at T0 and T60. When you say T0 to T60 here, definitely the catalyst just speed up the rate of chemical reaction, but that doesn't change how much is going to be formed at the end of the day. So basically it is going to shift to the left, but it finishes very fast. Even here it shifts to the left and then it finishes very fast. So basically that's what you were supposed to draw when it came to that. Thank you. Question for chemical equilibrium. We have smashed it. Then we go to the next question. The next question, which involves calculations. Yeah, it involves good calculations. Okay. Question 7. Here they're saying that here they're saying that identify metal M in unknown metal carbon, yes, and then produce. Okay, procedure is carried out. You have this mass of impure with this reacting as nitric acid. Yes, so the excess nitric acid will react with this sodium is barium hydroxide. Okay, assume that the volumes were predictive. All right, the following reaction takes place, and you're saying that you have this plus this gives you that. Okay, define the term strong base. This is a definition. We usually talk about it, but please define it. Strong base, basically, it must be able to dissociate completely when it dissolves in water. Yes. So they are saying that the number of moles, calculate the number of moles of barium nitrate, barium hydroxide reacted with the nitric acid. So we have to use the excess, whereby this one is not that big deal. How do we calculate that? So in this case, we're gonna say that a number of moles of barium nitrate is gonna be equal to the number of moles of barium hydroxide that reacted with excess. So but here we know that we know that. So we can use first principles or you can use formula. Yes, concentration times volume, whereby number of moles is equal to concentration. We have the concentration, which is 0.15 times volume, which is 20 divided by 1000. So that number of moles, let me check if I calculated it. Yes, I hope I calculated it. Yeah, it is equal to 0.003 moles. So that's how you can calculate the number of moles of that. And they're saying calculate the pH. The pH of solution after step 1. The pH of this solution after step 1 is basically determined by how much nitric acid was remaining. So in most cases, so this pH, because they said excess, so it means that we have to go for step number 1. Understand? Yes. But now we have to first compare the number of moles of barium nitrate, the number of moles of barium hydroxide compared to sulfuric nitric acid, because we know the number of moles of barium nitrate, barium hydroxide, then automatically we can find the number of moles. Okay, let's start by saying that mole ratio. Barium hydroxide to nitric acid. So barium hydroxide, barium is 1, and then nitric acid is 2. So what we're gonna do is we bring our barium hydroxide 0.03, yes, 2. So you have to multiply. It's gonna be 0.006. So this is the number of moles of nitric acid which are reacted with barium hydroxide. But now I need to find out the concentration of this in this 25 cubic centimeters. So I'll say that concentration is equal to times volume is equal to number of moles. So we have the number of moles of 0.006 is equal to concentration, which is I don't know, times volume, times volume, which is 25. Yes, because we want to know how much is in the 25, but this is not decimeter cubed divided by 1000. So that now concentration is going to be equal to this divided by that. Yes. So this times that divided by 25. So we just reciprocate it. And then now when you calculate, you get almost concentration 0.24 molar or moles per decimeter cubed. If you write capital M, it is still fine. So now C, the concentration is that. Now you need to take note of that, of this, before you go for this concentration. If this number of moles, if this nitric acid was a diprotic acid, I would have multiplied it by 2. But because it is a monoprotic acid, one hydrogen will be equal to the number of the moles of nitric acid will be equal to the number of hydrogen which are being produced. Understand? If it was sulfuric acid, I would have multiplied it by 2, because one molecule gives you 2 atoms, 2 ions of hydrogen. Yes. So we are there. So now, since it is monoprotic acid, everything is supposed to be flowing. Then the pH is equal to negative log of hydrogen concentration or hydrozonium ions. So now we know already the concentration as this, so pH is going to be equal to negative log of 0.24. Yes, and then the pH is supposed to be acidic, gives you 0.62. You can calculate and find out if it is the figure I've given is the perfect one. So yeah guys, that's how it's supposed to be obtained when it came to that. See, so it was not that very difficult if you knew how to interpret it. Now let's go to the next question, which is percentage purity. Okay, in percentage purity, base showed me who is the boss. Sorry, subscriber, sorry. It showed you who is the boss. So who is the boss? Tell me who is the boss. Is it you or is the base calculation? Sorry. Okay, let's go to so we are done with the pH, those 5 marks. Let's go to the percentage purity of this. Now we need to analyze something before you start doing any calculation. You need to first analyze and see exactly what happened. Yes. Okay, now they say that this is an impure with this mass, so it means that you're going to use that mass, but they say that in that mass only 85% of it is what is pure. Only 85% of it is what is pure. So it means that we have to find out how much number of moles are in that pure substance. All right. Now, number 2, they say that excess. They reacted this with the nitric acid. Understand? But the excess nitric acid, you see, excess nitric acid was reacted with barium. But now we don't know how much we started with, how much reacted, and how much remained after reacting. So now we have to calculate all that so that we can score these 8 marks. So now, how much we started with, we can calculate. How much we used, we calculated it already. Then after that, we can subtract. When we subtract, then we can know how much was used, and then we can use that to compare, and then we find the number of moles, and then after that we can find the mass. Did I say the mass? The molar mass in that regard. Let me just show you what I'm trying to say when it comes to this. Okay, let me start by saying that already now we know what is in excess. We calculated it. Did I rubbed it off? But we know what is in excess. So now what you're gonna start with is let's find out. So let's start with what is in here. How many number of moles are in here? Then we know how many moles which is here. Then after that we can subtract. Okay, say that 25 volume is equal to 25, and then concentration 0.4 moles, molar, let me just say molar, and then this one is cubic centimeters of what? Of nitric acid, nitric acid. Now we need to find out the number of moles of nitric acid which is in here. So we're gonna say number of moles is equal to C. we have different methods. You can use these generals, or but also first principles is still also fine. Times volume. So number of moles here is gonna be equal to 0.4 times 25 divided by 1,000. So number of moles here, when you do in the calculator, is gonna be 0.01. If you find an answer which is deviating a bit, please, it could be when I'm trying to press the calculator. Yeah, it could be, but the method remains the same. All right. So this is all the nitric acid which is in there, plus the excess, plus the one which reacted. Now let's find out what is in excess. Nitric acid excess. So nitric acid excess, we calculated it already, isn't it? By finding it here, isn't it? Yes, we calculated it already, and then we said that okay, let's do it. 20, still the same thing. Number of moles is equal to CV, whereby number of moles is gonna be 0.05, 0.15 times 20 divided by 1,000, so that I get to know remember it's supposed to be in decimeter cubed. Number of moles, this is the excess, the one which reacted with barium hydroxide, and this is the whole nitric acid. Yes, so the answer is going to be 0.003 moles. But these moles, these are the moles of barium hydroxide. You understand? But now you can use the mole ratio to find, because that's barium hydroxide. The mole ratio is 1 to 2. So it means that nitric acid is 2, while barium hydroxide is 1. So barium hydroxide is 1. So it means that if this is 0.003 for barium hydroxide, then nitric acid is going to be 2 of them, meaning that I have to say 0.003 times 2, which gives me 0.006. So these are the number of moles of nitric acid excess. Yes. So now once I get the number of moles of nitric acid in excess, now I can subtract this from this. So I'm going to say that number of moles of nitric acid used, because that's what we want. We want to know what is used, because the one which was used to react with this impure, this, so that yes, we know exactly. So now here I'm gonna have this is gonna be, let me see, 0.01 minus 0.006. You see, that is the number of moles. When you subtract, you must subtract it nicely, then 0.004 moles. So these are the number of moles of nitric acid used at the first run, the first instance. So now, since now I know the number of moles of nitric acid which got used, check. Now I know the number of moles of nitric acid which got used here. Now I can find the number of moles here, so that now I can use the number of moles is equal to mass over molar mass. Yes, so now since I know the number of moles which got used here, so now I can, yes, let's do the mole ratio again. Mole ratio is equal to nitric acid. How am I writing it? Nitric acid to M carbonate. Yeah, and there is something which you need to know here, that this M, because this is it must have a charge of 2, so that, remember, carbonate is like this. So this M must have a positive charge so that this cancel, and then you form M carbonate. So it means that this element is supposed to be in group 2. Yeah, must be in what? In group 2. So anyway, this is that. So we got it in, okay. I said this is 2 and then this is 1. Am I right? Let's go back. Yes, it's 2, it's 1. Good. Now these are number of moles, so this is 0.004. Yes, so automatically this is going to be 0.004 divided by 2, which gives me to be 0.002. So these are the number of moles of this. So now once I get the number of moles of that, now I can find number of moles is equal to mass over molar mass. I can find it. Yes. How am I going to find it? How am I going to find it? All right. Number of moles now I have as 0.002, yeah, is equal to mass. Do I know the mass? Yes. They said it here. They say that only 85% of the impure, so it automatically we have to first calculate this out, and then we find out which one is impure. So if you look at this, because they say that 85%, so I have 0.198 0.198 times 85%. So this is gonna give me the mass of pure sample. You understand? And then this gives me a figure of 0.1683 grams. So these are the mass. This is the mass I'm supposed to use. So in this case, I will say that 0.002, yes, I'm now substituting here, is equal to the mass, which is 0.1683, yes, then divide by the molar mass, M carbonate. Yeah, M carbonate. So M carbonate, because we don't know M what is M, but we know what is a carbonate, isn't it? Yes, we can find out what is a carbonate. So now this we can find out by this goes here, because if I want to find this, so it means that M carbonate is going to be equal to 0.683, yes, divided by 0.002, which gives me 84.1. Yes. So now if I get 84.1, then automatically I'm gonna say M carbonate is equal to 84.1. But now I need to find out what is M plus 12 plus 16, which is oxygen times 3, is equal to 84.1. So now, since I've got that, now I'm able to find out what is M. So M is gonna be equal to, when you add this, is 48. This is 48 plus 2 is 60. So it's gonna be M, then the 60 goes the other side, 84.1 minus 60. So M is gonna be equal to 24.1. So I have to go to the periodic table and find out what is 24. What is 24? I have to come here to the periodic table, then I find out which element has 24 as the molar mass, which is here, and the answer is magnesium. So M is equal to magnesium. So that could be the answer, and that's how the 8 marks got or came from. So it came all along from there. 1, 2, 3. Yes. That's how we got, or that's how you are supposed to get that question. Yes. Then we go to the next question. So I'm saying that is less than because the forward reaction is endothermic. What are you saying here? Let me check and see what you are saying. Okay. Let's go to the next question. Okay, I'll come back and then check and see. I don't understand what you are saying here. Because at temperature system decreased to this. No, they decrease the temperature at the forward reaction is endothermic. When they increase the temperature, they decrease the temperature. At 130, the temperature of the system decreased. Yes. I don't understand. I have to check see what you are saying. Yeah. Okay. I think that one is also done. Let's go to the last. This is the last. The second last question. All right. You are dying. You can't die now. I'll come back to you. I'll come back to you and then find out what you are saying. All right. Let's go to the next question. A cleaned pure copper. A cleaned pure copper. Question number 8. Yes. A cleaned pure copper is placed into a beaker. So okay, they placed it into the beaker. Question number 8. Okay, let me check and see what we are talking about. Okay. A cleaned pure copper strip is placed in a beaker containing colorless silver nitrate solution. Okay, shown. After a while, it is observed that the beaker becomes blue. The beaker becomes blue. Okay, what happened? Write down one other observable change that the solution beside the solution turning blue. So basically, the solution turning blue because copper is dissolving. So another thing is the mass of copper is gonna decrease because the copper reacts to from copper to ions plus 2 electrons. So the mass of this copper is gonna keep on decreasing. So that's another observation. Then 8.1.2, name the formula of the oxidizing agent here. Oxidizing agent, it means that it is reduced. It means that it's supposed to be lower in oxidation. It must have a weak reactivity. So it means that is oxidizing agent. It means that for it is reduced. So in this case, copper versus silver, you have to go to the reactivity series. You'll find out that silver is down. Therefore, silver is down. It is not reducing oxidizing agent. You see, silver is here while copper is there. Yes. No, it's this one. Because it's copper 2. Okay. Then we go to the next one. The next one, are they saying that name the formula of the oxidizing agent? We are done with that. They say the formula, so you write it like that. Then they say that explain the answer by referring to the relative strength. So we have said that in this case, silver is a strong oxidizing agent so that it can easily reduce or receive the electron from copper. So silver can easily receive electrons from copper than copper receiving from silver. Why? Because copper is more reactive, so it is easily give out the electrons, and then silver is able to pick up those electrons which have been released by copper. Hence, it becomes silver becomes an oxidizing agent. It causes copper to be oxidized. That's why it's called an oxidizing agent. The galvanic cell is now set up using copper and silver strip as electrode. A simplified diagram of the cell is shown below. So if the simplified cell is shown below, okay, saying right, name or the formula of electrode A. Electrode A. This is electrode A sharp. So since we are using silver solution, so A would be silver. And then solution B, because yes, this could be because it's silver, so in most cases we use silver nitrate. Therefore the same copper, so therefore it's going to become copper nitrate. It's copper nitrate. So did I say the formula? Yeah, the formula will be copper nitrate. Because copper is in group 2 of the transitional elements. Overall balanced net equation for the reaction. So automatically silver is what's going to happen. Silver is going to receive from copper. Therefore, we will say that copper, basically copper gives you copper 2 ions plus electron. And then silver 2 ions plus 2 electron. Silver is 1. Plus electron gives you silver solid because it is reduced. Therefore, when you write this copper 2 plus silver ion gives you copper 2 ions plus silver solid. But now this is 2 electrons, this one, so I put a 2 here, and I put a 2 there. So that is balanced. This is a solid, this is aqueous, this is aqueous, and that's a solid. So that is the equation which you're supposed to write. Then 8.4, they're saying that the salt bridge contains nitrate, sodium nitrate, potassium nitrate. They're saying that write down the ion that will be moving into the silver solution, and then choose potassium and nitrate. Obviously, because this one is reduced, silver is reduced, the strong oxidizing agent. So in this, the one which is reduced is always the cathode. Then one which is oxidized is always the anode. So, and don't forget that anode is the negative, and then the cathode is the positive. Yeah. So now the positive charge will go to the positive, and then the negative charge will go to the negative. Why? So that it keeps it be positive. Why? Because this is a negative charge, negative terminal. So electrons move from there to here. So when they move from there to here, it leaves this to be less negative and start to become positive. So what happens? So the potassium will the nitrate will come and then keeps it negative again. And then this one, the potassium, because now it receives the negative from this side, it keeps on neutralizing this, and then now it becomes less positive. So the potassium ion will come and then it makes it more positive so that the reaction can continue. So in this case, we shall say that potassium will go to silver, and then the other one, nitrate, will go to the copper. That is the question. Write down the formula of the salt into silver. So in this case, it is potassium. So you just say potassium ion. Give a reason, because silver is on the cathode, which is positive, and then the electrons try to neutralize the positive charges. Therefore, to prevent the cell from being impaired, positive charges must be supplied so that it keeps the terminal more positive. Yes. Then the last question, the last question. Okay, the last question. Let's writing geography. So you will make it. Okay, let's just go to the last question. Okay, the last question is saying that also requires some calculations. All right, let's see if we can do the calculations, and then we can win it. All right, they're saying that define electrolysis. Electrolysis basically is splitting water using electricity. Or use this other compound, you split them, decomposition of these compounds using electricity. So basically that's electrolysis. And then electro is electron, which means electricity, and lysis comes from the word split, which means you split the substance or decomposing the substance using what? Electricity. Yes. Write down the reaction that need to first read. An electrolytic cell is electrolytic cell. It means it has a battery. Is put to purify this the piece of copper that contains silver and zinc as impure. And then they're saying that the simplified diagram of the cell is shown in the electrode sharp. All right. Now they're saying that what is the cathode? Is the cathode, what is the anode? Okay, basically this is the anode, and then this is the cathode. Why? Because anode is where oxidation occurs, so it gives the electrons so that the electrons can move in that direction. And then the anode, the cathode, it's the positively charged, and this is the negatively charged. So yes, did I say that? Yes. Okay, now we are saying that now electron this is gonna dissolve, so it's gonna dissolve, and then in this case, this what impure copper is gonna be this, and then the small pure copper is gonna be that. So it means that copper 2, which is a solid, is gonna give you copper 2 ions plus 2 electrons. Then the electrons will have to migrate to this side and then react with the copper ions from the solution, and then after that it forms more solid. So that now this one increases in the size. All right, let's go to the question and see. Write down the reaction that takes place at Q. Definitely, because we say that copper ion 2 ions plus 2 electrons gives you copper solid. Why? Because now it moves to that side, and that's where reduction takes place. So this is a reduction. Yes. In which direction does the electron flow in the external circuit? Okay, we have said it. That's the direction of electron, and then I'm saying that calculate in which direction also. So it means that it's gonna be R to Q. Then you're saying calculate the current needed to form to form 9 grams of 9 grams of copper when the cell operates. This, you have different methods you can use, but also you can use first principles. It's also cool. But now you need to find out how many number of moles. So you have these formulas. You have these formulas which you're supposed to use. See, yes. So basically, we're gonna say that number of moles. We need to find the number of moles. Number of moles is equal to the 16 divided by the molar mass of copper, which is 63.5 from the periodic table, and then it gives you 0.252. Maybe they'll give you a mark there, sharp. Then after that, but now I need to know how many electrons are supposed to be now we are converting these moles into number of moles in terms of electrons. So now it's going to be copper 2 ions plus 2 electrons gives me copper solid, so that it is deposited in here. And then now it means that each 1 mole of copper requires 2 electrons. Therefore, I will say that 0.252 times 2 will give me 0.5039. These are the moles, yes, moles of electron. Understand? Yeah, for that reaction to take place, for that reaction to electron, for that reaction to do what? To take place. Then you have another what are you supposed to do here? Now we need to convert this into charge. So let's convert this into charge, whereby we apply the Faraday's law or Faraday's constant, whereby charge is going to be equal to 9648385. That is a constant, yes, times this number of, yes, 0.5039. So basically the charge here is going to be equal to 4.862 times 10 power 4. Yeah, and this charge is measured in coulombs. Understand? Yes, after finding the charge in coulombs, then it means that it's easy. But check here,